Understanding Istio's architecture and core concepts provides a solid foundation for effectively using it within your Kubernetes environment, especially in a microservices setup. Istio's architecture consists mainly of the control plane and data plane components, which interact to manage and monitor network traffic between microservices securely and reliably. 1. Overview of Istio architecture. Istio is structured with the following primary components. Control plane, responsible for configuring and managing the proxies deployed in the mesh. Data plane, manages network traffic between services through a set of Envoy proxies, which intercept and manage all inbound and outbound requests for each service instance. Let's explore each part of this architecture in detail. 2. Control plane. The control plane is where Istio's intelligence and configuration management happens. It includes components that manage routing, security, policies, and observability for the services within the mesh. Key components of the control plane. Istio. Pilot, within Istio, configures the Envoy proxies that run alongside your services. It provides them with rules for traffic routing, load balancing, and resilience policies like circuit breaking and retries. Galley, partially integrated into Istio since earlier Istio versions, used to be the component for configuration validation, but its role has since been merged to simplify Istio's management. Mixer was previously responsible for telemetry and policy enforcement, but has been replaced by Envoy's native capabilities and direct integrations to reduce latency. Citadel, security management, handles service-to-service security by issuing and managing certificates for MTLS mutual TLS. This certificate-based authentication mechanism encrypts traffic between services, ensuring both data confidentiality and integrity. In Istio 1.5 and later, Citadel is merged into Istio, streamlining security management. Injector automates the injection of the Envoy proxy as a sidecar container in each pod. The proxy is what intercepts and manages traffic between your services, enabling the data plane to enforce policies and manage traffic in real time. Telemetry, observability. Collects metrics and logs and integrates with tools like Prometheus, Grafana, and Jaeger for monitoring and tracing service-to-service communication. This component helps track performance metrics, identify bottlenecks, and optimize the network flow. 3. Data plane. The data plane is responsible for managing all network traffic between services within the mesh. It consists mainly of Envoy proxies deployed as sidecars alongside application containers. Core functions of the data plane. Traffic management. The sidecar proxies intercept inbound and outbound requests from each service pod, directing traffic based on configurations from the control plane. Proxies enable advanced routing, for example, load balancing, fault injection, and request retries, and support different types of traffic splitting, such as canary releases or A/B testing. Service discovery. Envoy proxies use the service registry, where all services are registered, to find and connect to the appropriate service endpoints dynamically. Istio integrates with Kubernetes to keep track of service IPs and ports automatically. Security. Istio enforces MTLS between services, requiring them to verify each other's certificates before establishing a connection. This is achieved by issuing unique certificates to each service, signed by Istio Citadel. The sidecar proxies decrypt and encrypt the traffic, ensuring end-to-end encryption within the service mesh. Observability. Proxies collect metrics, logs, and traces, which are then sent to monitoring systems. They track request counts, error rates, latency, and other useful metrics, which help operators monitor application performance and diagnose issues. 4. Istio's core concepts. Sidecar proxy pattern. The sidecar proxy pattern involves deploying a separate container, Envoy proxy, within each service pod. This proxy intercepts all network traffic, giving Istio control over communication between services. This approach isolates network-related concerns from the business logic, improving both security and observability. Virtual services and destination rules. Virtual services define how traffic should be routed for specific requests, allowing operators to implement advanced routing strategies like weighted load balancing or fault injection. Destination rules specify policies applied to the service instances, including load balancing and connection pooling settings. Together, they provide granular control over routing and network behavior. Gateways. Gateways manage inbound and outbound traffic to and from the mesh, controlling which requests are allowed to enter or exit. Ingress gateway is used to allow traffic into the mesh, while egress gateway controls outbound traffic to external resources. MTLS, Mutual TLS. MTLS is a critical Istio feature that ensures secure, encrypted communication between services. It involves mutual authentication, where each service verifies the other's certificate before establishing a connection. This prevents unauthorized services from interacting within the mesh and secures data in transit. Policy and authorization. Authorization policies allow you to define access control rules based on request attributes, such as source or destination of the traffic, ensuring only authorized traffic flows between services. In Istio, this is often implemented through role-based access control, RBAC, or attribute-based access control, ABAC. Telemetry and observability. Istio's observability tools monitor traffic patterns, metrics, and request traces. They allow you to visualize service health, analyze latency, and identify bottlenecks. Integration with monitoring tools like Prometheus, Grafana, and tracing tools like Jaeger provides insights into the service mesh. 5. How the control plane and data plane work together. The control plane sets rules and policies that the data plane enforces. For example, a virtual service defined in the control plane specifies traffic routing rules, and Envoy sidecars in the data plane apply those rules to actual network traffic. When traffic flows between services, the data plane proxies manage that flow based on configurations sent from the control plane, such as security policies or traffic load balancing rules. The control plane also collects telemetry data sent by the data plane proxies, which it then forwards to monitoring systems.